Hi, so let's take a look at craving today. Craving's an interesting phenomena, and it isn't just about food or drugs or alcohol or things like that. It can be about situational stuff, craving that things are different than they are, which is a big issue for lots of people. And all of those kinds of things throw us off balance when we are wanting something that we don't have, or wishing that things were different, or wondering when something's going to change. That tends to distract us. And there's another thing that we'll kind of get into during this whole thing, which is called the default mode network of our brain. That's what our brain's doing, or our mind is doing. If you consider that the mind is the brain in action, and the brain is the functional parts. That's what our mind is doing when we're not paying attention to it. And that's where we get ourselves into a lot of trouble, actually, is not paying attention to what's going on in our head. I've talked about metacognition before, which is uh, that ability to pay attention to what we are thinking about. And if we're thinking about stuff that isn't going on at the moment, or if we're not paying attention to what we are thinking about, and our mind sort of wanders down rabbit holes that we don't need to go down, those are the kinds of things that can get us into trouble. So this is Judson Brewer. He's a addiction psychiatrist and a neuroscientist, and he's going to explain some stuff here.
So you've been witnessing a series of unnatural acts. You've been watching some of the smartest people in the world take their passion, their discoveries, their triumphs, their failures, and package them in 10 minutes. And that is really hard to do. And every one of them has stayed on time and on track. And you'll have a chance to go at them at lunch because, believe me, you could spend the next year with any one of these people and learn just incredible things. So our next speaker. If you've got cravings, if you're dreaming of chocolate, if you remember that long-lost kiss, Judson Brewer will help you understand why this happens and what you might do about it. He's the Director of Research and Innovation at the Mindfulness Center at Brown University, a pioneer in the field of habit change and self-mastery. And if you doubt me, just ask the US Olympic team.
We're in the middle of an obesity epidemic. We're in the middle of an opioid epidemic. I think we all know this. And what did I learn in medical school? Willpower. So if my patients want to quit smoking, set a quit date, tell all your buddies to help support you. We'll give you some medications to help with the side effects, and then quit smoking, right? What I learned in medical school about trying to lose weight. We learned a formula that apparently is still being taught. Calories out versus calories in. It's not that the formula is wrong. But we're told, we tell our patients, oh, just make sure you eat salad instead of cake. Make sure you exercise. But you can just see how these go up against great odds. So what I'm going to argue is that we might actually not be tapping into something in the brain and the mind that we actually already know and that we're just not paying attention to. There's a guy back in the 50s, many of you might know him, B.F. Skinner, studied animal behavior. In fact, he found that he could train pigeons to win a cross-court shot, in ping pong. This video would play. Anyway, you get the idea. Teach pigeons to win a cross-court shot in ping pong for a food reward. There we go. He came up with a theory, called it operant conditioning, or positive and negative reinforcement. In fact, Eric Kandel won the Nobel Prize for this, showing that this is evolutionarily conserved all the way back to the sea slug. So we know the elements. I think of this as a habit loop. We have a trigger, a behavior, and a reward. So we see some food, we eat the food, and our stomach sends the signal to our brain that says, remember what you ate and where you found it. So rock solid theory, here's Eric Kendall receiving his Nobel Prize, reproducible all the way back to the sea slug. Now, I learned about this in college. I didn't think that much of it, but as I was starting my career as an addiction psychiatrist, I was really struggling to help my patients change their behaviors. Working with my patients who were addicted to cocaine or heroin and just saying, stop, control yourself, didn't work very well. And I had this aha moment, I had this light bulb moment where I realized, wait a minute, this explains a whole lot more than just these classical addictions. We learn to eat food, not when we're hungry, but when we're anxious. We learn to take pills to numb ourselves from emotional and physical pain. We learn to look at cute pictures of puppies on Instagram when we're bored. In fact, social media is designed for those likes and those retweets. Food is engineered to be addictive. So why doesn't willpower work? Well, we do know some things neuroscientifically. One is that willpower relies on a part of the brain called the prefrontal cortex. Interestingly, this is the youngest and weakest part of the brain from an evolutionary perspective. It's the first that goes offline when we get stressed out. So if we can't rely on this, what can we rely on? What I'm going to argue is that awareness itself might help us change behavior. You might think that's crazy. I actually gave a TED Talk on this a couple of years ago. It ended up being the 4th most watched talk of the year. I don't think it was me, but it was the message, which was very simple, which is awareness trumps self-control. And by this, I mean bringing awareness to the results of our behaviors. Reward-based learning is based on rewards, not on the behaviors themselves. Pigeons aren't particularly prone to playing ping pong, but they will play for food. So there's another bit of neuroscience that you need to know that helps explain this. It's a part of our brain called the orbitofrontal cortex that's involved in reward valuation and storage. So for example, if I eat some milk chocolate, my brain's going to compare that to other foods that I've eaten. Say broccoli. My brain says, oh, milk chocolate, I'll have that over broccoli. If I eat some dark chocolate, my brain compares those. And for me, dark chocolate trumps milk chocolate. And so it sets up this hierarchy of rewards. I think of the OFC as the BBO part of the brain. It's always looking for that bigger, better offer. So how does this relate to awareness? Is awareness actually enough to hack our brains into better health? This question actually helped change my career from studying molecular biology to learning cognitive neuroscience, even founding a startup company to make app-based behavior change programs so we could answer this simple question: is awareness enough to change behavior? We did something really simple. We used mindfulness training to help people pay attention to the results of their behaviors. Here are some examples. So somebody who used mindfulness training to work with smoking. Pay attention to the results of smoking. What happens? Reward value drops. Pay attention to the results of overeating or stress eating. What happens? The reward value drops. And with this drop in reward value, it opens up the space for that bigger, better offer. Now, what if I said that awareness itself, and in particular, the attitude of curiosity, is that bigger, better offer? Here's an example of somebody using one of our app-based mindfulness training programs for anxiety. She said, when I first started the program, I didn't quite buy into the benefits of curiosity. Today, I felt a wave of panic, and instead of immediate dread or fear, my automatic response was, that's interesting. So you can see how her brain was starting to prefer curiosity to worry or anxiety. It feels better. Now, examples are illustrative, but results are definitive. So my lab's gone on to do the studies. And this is still an early field, but the early results are promising. For example, in a study of obese and overweight women who received app-based mindfulness training for eating, we found a 40% reduction in craving-related eating. We saw a 35% reduction in eating to cope with negative emotions. So you can see how they're hacking into this reward-based learning loop. In a study of anxious physicians, right, physician anxiety and burnout is at epidemic proportions, we saw a 57% reduction in clinically validated anxiety symptoms. We use the GAD-7 in this case. We even saw a 50% reduction in some burnout symptoms, even though we didn't train them in burnout at all. But the two are highly correlated. Now, we've gone on to map the brain regions that are involved in this process and the networks. There's a network called the default mode network. Many of you are familiar with this. This network gets activated when we get caught up in craving. It's activated when we get caught up in perseveration or rumination when we're anxious. And this same network gets deactivated when we're paying attention. I'm going to let Anderson Cooper describe this to you because he does a much better job than I do.
Exercise. We've got the physical, exercise components down, and now it's about working out how can we actually train our minds.
Dr. Brewer is trying to understand how mindfulness can alter the functioning of the brain. He uses a cap lined with 128 electrodes.
We're going to start filling each of these 128 wells with conduction gel.
The electrodes are able to pick up signals from the posterior cingulate, part of a brain network linked to memory and emotion.
This is all just picking up electrical signal from the top of your head.
Since attending the mindfulness retreat, I'd been meditating daily and was curious to see if it had an impact on my brain.
We're going to have you start with thinking of something that was very anxiety-provoking for you.
Okay.
When I thought about something stressful, the cells in my brain's posterior cingulate immediately started firing, shown by the red lines that went off the chart on the computer screen.
Just drop into meditation.
Okay.
When I let go of those stressful thoughts and refocused on my breath, within seconds the brain cells that had been firing quieted down, shown by the blue lines on the computer.
That's really fascinating to see like that.
Dr. Brewer believes everyone can train their brains to reach that blue mindfulness zone, but he says all the technology we're surrounded by makes it difficult.
So we can actually start to bring all of this stuff together. We've just finished a study where we brought people in who wanted to quit smoking. We could scan their brains at baseline after we showed them smoking cues, and we could measure how much their default mode network got activated. Then randomize them to get mindfulness training or gold standard treatment, scan their brains a month later, and see if we could predict clinical outcomes. What we found was a very strong correlation between a reduction in default mode network activity and a reduction in cigarette smoking, and this was specific to the mindfulness training group. We also saw a dose-dependent relationship. The more modules people completed, the better they did. No correlation in the control group, even though they completed the exact same number of modules. And so, just bringing all of this together, what I'm going to argue is that we actually know a whole lot about how addictions and habits are formed. Everything from everyday addictions like our cell phones and eating to classical addictions like cocaine and heroin. We also know that we can start to hack this process by understanding how our minds work. We can bring awareness in to do two things. One, help us become disenchanted with these old behaviors, but also bring that bigger, better offer in, like curiosity, that might have been right in front of our noses all along. Our brains are actually really strong. We just have to really understand how they work, and we can tap into their potential. Then we can move from, pushing on a door that's really closed, hoping that we can open it, to stepping back, looking around, seeing that there's a handle, opening it, and walking through. Thank you very much.
Move that. So the instruction, this is a little poem by Mary Oliver. The instructions: pay attention, be astonished, that's that curiosity piece, and tell about it. You tell yourself about it or tell somebody else about it. But that awareness of what's going on in our brain, and I've talked about that lots and lots of times, and the multiple breathing exercises that I've shared with everybody are really about bringing our attention back to what's going on right at the moment. And that starts to settle down that default mode network, which is driving a lot of those thoughts that are getting us into situations that we really don't want to get into, like I need ice cream, or I want to drink, or whatever it is. Those thoughts are kicking around in that default mode network. They're wandering around in our daydreaming. And if we don't pay attention to what we're doing, it tends to find rabbit holes, like I said before, to jump down. When we start to pay attention to what we're doing, our focus changes, that default mode network settles down, and things will start to change for us. But that's when you have that opportunity to notice that random thought that wandered in there that you don't really need. So here's a little more of Judson, and this is another technique that works pretty well.
When you're anxious, one of the best things to do is to slow down and focus on your breath. But what about when you're so anxious or stressed that regular breathing exercises don't seem to work? In today's video, I'll teach you a simple but effective exercise that brings in more of your senses to help cut through the anxiety so you can be calm and focused in the present moment. I'm Dr. Judd Brewer, addiction psychiatrist and neuroscientist specializing in anxiety and habit change. Let's dive right in. In previous videos, I've suggested that people try taking a few mindful breaths or grounding themselves by bringing their awareness to their feet when stress is starting to ramp up or they're really feeling anxious. The feet are a great grounding to keep you in the present moment because our feet aren't the place where we feel or hold anxiety. When we're stressed or anxious, these show up in our chest, our shoulders, our jaw, and even in the muscles around our eyes. Yet if you're really stressed or anxious, even paying attention to your feet can feel a bit challenging. Let's talk about why, and then I'll show you a short breathing exercise that's especially good for kids that can also help us as adults stay grounded. First, some science. There's a part of your prefrontal cortex, that thinking and planning part of your brain, called the dorsolateral prefrontal cortex, or DLPFC for short. It's toward the front and to the side of your brain, roughly here and here. The DLPFC has been shown to be important for working memory, the part of short-term memory that's concerned with immediate conscious perceptual and linguistic processing. Basically, it holds information for you to use right now. For example, if someone tells you a phone number and you repeat it to yourself so you can hold it in mind long enough to dial that number, that's the DLPFC. Or you have a few items you're trying to remember to pick up at the grocery store in the next few minutes, you've got to remember those. That's also the DLPFC holding those in mind. Have you noticed that it's harder to remember these types of things when you're stressed or when you're anxious? This may be in part due to that memory space is limited in your brain. You can think of your DLPFC as being analogous to the random access memory or RAM of your computer. If your computer has a lot of RAM, you can run a bunch of programs at the same time. If it doesn't have that much RAM, it gets slower each time you use a new app and use that space up, signaled by that spinning wheel of, hey, you're overtaxing me right now on your computer screen. And eventually your computer crashes if you keep pushing it. Your brain is similar. The DLPFC can only hold so much information in working memory. If you're really worried about something, that worry thinking takes up space so that it's harder to remember your grocery list or what someone just said a few minutes ago on a conference call. So how can you free up that space to get your brain working more effectively? I've mentioned before that mindfulness practices can help get your thinking brain back online. But sometimes this can be really challenging. You bring your awareness to your breath or your feet for a few moments, but because your working memory has been really filled with worry thoughts, this can feel forced or not enough to help your mind and body, as in your brain and physiology, calm down. So here's a little trick you can play with to reboot that RAM in your brain. I love this because you can use the excuse of teaching it to your kids and practicing it with them, but it really works for all ages. It's called the 5-finger breathing. Let's do it together, and then I'll tell you how it works. Start by placing the index finger of one hand on the outside of your pinky on the other hand. As you breathe in, trace up the outside of your pinky. As you breathe out, trace down the inside of your pinky. As you breathe in, trace up the outside of your ring finger. As you breathe out, trace down the inside of your ring finger. As you breathe in, trace up the outside of your middle finger. As you breathe out, trace down the inside of your middle finger. You can continue this as you trace your entire hand, and then you can reverse the process going from your thumb to your pinky. What's it like even if you trace a few fingers? Better than getting caught up in worry, no? Five-finger breathing is great because it brings several of your senses together at the same time. You watch and feel your fingers at the same time that you're paying attention to your breath. This is not only multisensory, seeing and feeling, but it requires awareness of multiple locations as well. You're feeling two of your fingers, one on each hand, and your breath at the same time. This takes a lot of your brain's RAM to do, perhaps enough that it crowds out those worry thoughts. If you only pay attention to your breath, those worry thoughts can still be pretty loud in taking up that memory. If you use up all that RAM with multisensory and multi-location awareness, you might forget what you were worrying about for a moment. And as you do this for a minute or so, you also calm your physiology down, so that if those thoughts come back in, they aren't as convincing because they don't have the same emotional tone. Without that arousal, they have less weight behind them and are easier to let go, or simply see as thoughts instead of something that you have to act on right now, even if the acting is only the act of worrying. Remember my previous video about worrying being our brain's way of doing at least something when we can't really do anything about a situation? So if you have kids, teach them five-finger breathing. Then practice this as a family. You can do this before each meal, before nap time or bed, or at other discrete transition points in the day. And if you notice that you're starting to get worked up sometime during the day, take a moment to tell them how you're feeling. Oh, I'm feeling a little stressed right now. Then ask them for their help, which empowers them and helps them feel in control. Hey, can you help me calm down by leading me in a five-finger breathing exercise? If you don't have kids, no worries. Let your inner kid help out and guide it yourself. Let's finish with a page from the book, The Boy, the Mole, the Fox, and the Horse. What is the bravest thing you've ever said? Asked the boy. Help, said the horse. So see if you can ask for help when you need it today, maybe from your kids or even from yourself. See if five-finger breathing can help you reset your physiology so you can keep your working memory working and your thinking brain thinking. Onward, together. We'll see you tomorrow.
So that whole staying present piece, using mindfulness to help us uh, distract our brain from whatever it's doing when it wants to doing whenever it's doing what it wants to be doing without our input, becomes really, really useful. So it helps us pay attention to what we are doing, but it also helps us notice when random thoughts occur. So that chocolate thought floated in there, and we are now aware of it. And once we're aware of it, we can say, "Oh, hi, I don't really need you." And it's never useful to get mad at ourselves. Just acknowledge those thoughts as they come in, and just let them float by, or tell them that you appreciate that they came, so that you can remember to go back to paying attention to what you're doing at the moment. So that I need chocolate, or I need whatever, or that other sort of really less helpful thought that lots of us have, is that somewhere or another we're not enough. uh, that really kind of eats away at us, and can be emotionally damaging. So learning to pay attention to things frees us up. So pay attention to what you are paying attention to. And I'll stop the share, and I will see you tomorrow. Thank you.